now we're going to look at the properties of definite integral. So the first property of definite integral is that if we're given the interval from a to a, then the area below the curve would be 0. And this should be very clear because on a graph, if we're given to calculate the area from an interval to the exact same interval, then we pretty much are given no area at all to calculate. It should be pretty straightforward. Well, the second property is that given the interval from b to a, we can also calculate it as the interval from a to b if we add a negative sign in front of the equation. So sometimes we're asked to calculate the curve from point A to point B. And that can get confusing at times or during your calculation. So if you want to switch them, all you have to do is remember to add a negative sign in front of them, and in front of the integral, then you can switch A, switch B. Okay? And sometimes because one of them could be a negative number, you can also switch them to make it a little more simple for yourself. Now, let's look at the third property. So the third property here, we're given that if we have the integral, given the interval from a to b, we can separate it into two parts and add another c value in between that, right? So we can calculate the integral from a to c plus the integral from c to b, and that would be the same as calculating integral from the interval a to b. So for example, if we have a graph here, and we have interval a to interval b, and then we add another interval in between it, call it c. We can calculate the area of here first, and then we can calculate the area here, and then add these two together. It will be the same as calculating the entire area together. Now let's look at the third one. Okay, the third one is important because we will be using this a lot later on as we get into more difficult definite integrals to calculate. So this one we're given again the interval from a to b, but inside the bracket here we have fx plus or minus g of x, and now what this is saying that we can separate this integral into two parts and just calculate the integral of fx first, and then calculate the integral of g of x, and then depending on what you're depending on if you're subtracting or adding, we can subtract and add, and that would be the same as just writing it as an entire thing. So we can separate it into two parts. This can make calculating definite integral a lot easier later on, so it's very important to remember this rule. Now the fifth one is especially important. The fifth one is pretty much saying that if we have a constant in front of our f of x here, we can move the c out to the front of the integral. So we can move c, as you can see here, we can move c out. So let's have an example here to make it a little more clear. So if we have interval from a to b, but we have the integral of 4x, we can move the 4 out here in front, so 4a to b x, right? And then we can find the integral of x first, so the integral of x should be 1 over 2x squared, and then times it by 4. So we can do that at the very end after we've calculated the integral of our variable here. So that would give us 2x squared as our final integral. This can make your life a whole lot easier. It's very important that you master this property here and remember it because it's very important later on.